All right, so today we are going to take a look at a second degree type 1. That's right. There are two types of second degree heart blocks. We have a second degree type 1 and a second degree type 2. If you're looking for the type 2, this is not the video for you. But we're going to go through the process for a type 1. So a second degree type 1. All right, so let's tackle this. Our first thing is, again, as with every EKG, we want to know whether or not this is a readable strip. And if I take a look at this, I can't identify waves. I don't have any real abnormalities here, so I'm going to say that, yes, this is a readable strip. Next, I want to know, do I have P waves that are present or absent? Now, again, all I'm doing here is taking a look to see if there are P waves. So when I look at this, I'm going to just change the color here. So I have a P wave, a P wave, a P wave. This looks like a P wave, a P wave, a P wave, a P wave. This again, it doesn't really look like a T wave. Looks like there's something else that's there, and a P wave. So P waves are present. Do I have a P wave for every QRS complex? Again, I'm going to go P wave, QRS, P wave, QRS, P wave, QRS, P wave, QRS. All right, so I'm looking here. And it says, do I have a P wave for every QRS? And the answer here would be yes. Do I have a QRS for every P? And now I'm going to reverse this, and I'm going to say QRS P. Oh, I got an extra P here. QRS P, QRS P, QRS P. I'm missing one here. QRS P, QRS P, QRS P. Now, I know that there's a P wave there, but I can't tell where that's supposed to be, so we're going to kind of eliminate that out, right? Okay, so when I come to my answer here, I want to take a look at whether or not I have a QRS for every P wave, and that now tells me no. Now, if you haven't seen any of my other videos, I would obviously encourage you to go take a look at those, but when I'm following the rules, once I get to a QRS for every P and I answer no, I'm either down to a second degree 1, a second degree 2, or a third degree block. Because this tells me that I have more P waves than QRS complexes. So it takes me down to those three. Then I just need to follow the rest of the rules. So let's get some of these things out of here. So now when I take a look at these, I need to answer some questions. I want to know about the PR interval. Is it consistent and is it regular? So these areas or these questions here for number 5 are going to be very important to me. So to do this, I'm going to pull in my calipers. And when we pull in the calipers, I'm going to start off here with a P wave. So I know that this is a P wave, and I know that this one is a P wave, right? So I want to know, are these all going to be P waves? Whoops. And when I look at this, lo and behold, what happens is that all of these P waves are lining up. So what this tells me is that definitely they're all P waves, and in addition to that, they all appear to be regular. That is also a key factor. Okay, so the consistency is yes, they are consistent. They are regular. So we know that they are regular. Now we're going to take a look at a PR interval. Okay, so again, we're going to start right here where we know there's a PR. And we're going to adjust this. So this PR interval, before I even measure anything else, I want to come down to the next one, and what do I notice? I notice that it has gotten progressively longer. It is not the same. So I'm going to measure this one. Now I can move this, and lo and behold, I find that it got again a little longer. Now here is a P wave. So my PR interval is going to be variable. So I have a variable PR interval. And when I have a variable PR interval, it essentially takes out a third degree heart block. It takes out a second degree type 2. And it leaves me essentially with this answer right here, which is a second degree type 1. This is a Winky Bach. So we're not done yet. So we got to make sure that everything is still okay. So we're going to take a look at our atrial rate, and we found out that it was regular, so we can measure a P to P. And when I measure my P to P, here's 300, 150, 100, here's 75. So if I were to take a look at this, there's 5, 10, 15, 16, 17. So again, I have 17 blocks. So I know that I put 1500 inside the box, and I divide that by 17, and I get an atrial rate of 88. Now, what did I do with this? Again, take a look at some of the other videos that I have, and it will explain how we got those. But essentially, 1,500 small blocks pass across the stylus each minute, and I counted the blocks that are here. We went 5, 10, 15. There's 2 more. That would be 17. So I do 17 into 1,500, and that gives me 88. Okay? So that's why I have that as my answer for the atrial rate. Now my QRS, when I take a look at my QRS, I notice though, is it regular or irregular? So I'm going to measure this a little bit. And it is now, we're missing right here. We're missing a QRS. So when I miss this QRS and I move things along, I notice that now it is irregular. So my QRS is actually irregular. So in this case, I need to count the number of QRS complexes that are within this 6-second strip. So I have 1, 2, 3, 4, 5, 6, 7. So when I take that and I multiply it by 10, this tells me that the ventricular rate is actually at 70. I don't want to forget about my QRS duration. We want to make sure that it's following normal conducting pathways. So we're going to measure that as well. Again, we already know what it appears to be, but we want to verify everything. So we're going to measure this. And that looks like 2 blocks. So QRS duration here is at 0.08. And we say when we have that it is within normal range. So therefore, our definition here is a second degree type 1. Now, once again, what's happening is that the AV junction is controlling everything. The AV junction is controlling everything. So let's take a look at how this can occur again. So again, we have our heart. And when you have your heart, okay, we said that up here is going to be your internodal pathways along with your SA node. The SA node is firing. There's no problem with the SA node. We're actually able to see that the SA node is firing because there's P waves and they appear to be normal. So the SA node in this case is okay. It's doing its job. The problem is right in here. It's going to be somewhere in this AV junction that is the problem. Okay, so what's happening is that think of the AV junction is actually snoozing. Okay, it's snoozing, or in this case, it's actually more lethargic. And what I mean by that is that it's not acting the way that it's supposed to. So it's delaying things a little bit longer, and it delays a little longer, and then eventually it doesn't let a beat come down through. Now, what's kind of scary about this is that the ventricles could or should, depends on the rate that's here, this is probably why it didn't happen, is that this rate, there should almost be some backup that is occurring here, and it's not. So in a second degree type 1 or a Winky Bach, okay, so they also call it the Winky Bach, or they can also call it, you'll hear people call it a Mobitz 1, okay? So you can hear it either way, actually 3-way second degree type 1, a Winky Bach, or a Mobitz type 1. This is, again, the problem is that the AV junction is starting to become lethargic, and therefore it's holding up each beat for a period of time that's longer than the one before until it eventually blocks one. It doesn't allow it to come back down through. and it's typically consistent. So it occurs consistently, and this tells us that there's the problem. It's happening consistently over time, and under the definitions of a high degree heart block, this is a relatively lower one. So this is a second degree type 1, and that's why they would consider it a lower one. It's typically one that does not progress to a second degree 2 or a third degree heart block right away. So again, take a look at your patients, and hopefully this gave you some insight, and now you understand a little bit more about a second degree type 1.